So in this new video we will discuss uh, point number 4 of our welding specifications. In this video, this item pipe cutting and bevel at the preparation. The pipe should be supplied with bevel end according to the specifications. Any pipe cutting bevel required aside will be conducted by machining or mechanically guided thermal cutting. So what are the two methods that can be adopted for doing the beveling inside? That is machining and mechanically guided thermal cutting. So all cut surface shall be finally prepared and beveled by grinding or machining to clean bright metal. So up to what is grinding and machining, up to which level? Up to clean dried metal. After head has been prepared for welding, visual examinations and the MPR shall confirm that the preparations are smooth, uniform, free from tears. What are the two methods we adopt to confirm the preparations are smooth and uniform, free from tears? This visual examination and the magnetic particle test. So if pipe is cut back more than 25 mm from the factory bevel, what will happen? The pipe end also shall be ultrasonic tested. So if there is a cutting more than dash 25 mm, the ultrasonic test it should be ultrasonically tested to ensure that no laminations are present. What is laminations? That is the laminations are layers actually. It's a defect actually. It's a horizontal defect we can say. So laminations are not to check this. We need to do what? Ultrasonic test it. If it is cut back more than 25 mm. So weld bevels containing defects shall be cut back and re-beveled, and weld bevels shall be checked to ensure correctness of the profile. Profile means we have this included angle, root face, etc. So we need to ensure that profile of the bevel during when we are doing the re-bevel. The weld bevels and 25 mm width adjacent to the bevel must be clean, free from moisture, oxides or other foreign matter prior to the application of preheat or welding. So that's about beveling in our special specification. In general specification, we need to know more. Okay. Here, this preparation of cutting of carbon steel may be done using machine grinding, machine guided gas torch or plasma or cuttings. Here in our specification, we are not doing gas torch or plasma cutting. Gas torch and plasma cutting are only to be used where it's not practical to use mechanical methods, but in our particular specification it is avoided. So what is this plasma arc cutting and gas torch, and what is this difference? It is we checked our AI, we came across this one. Plasma cutting are both they are both a thermal cutting process. By differ fundamentally in their working mechanisms, material compatibility, and applications. Key difference is that plasma cutting is faster, it is more versatile for cutting or electrically conductive metals, thin to medium size, while flame cutting is specialized for thick carbon steel and low alloy steels. So how they function? This plasma cutting, it uses a high temperature, high velocity jet of ionized gases or plasma arc to melt and expel the metal. So it is used for all electrically conductive metals, carbon steel, stainless steel, aluminum, copper, etc. It is best for thin to medium sizes like a 32 mm for handheld but can go up to 6 inches, that is 150 mm with a high powered machinized system. Cutting speed is faster on thin or medium materials. Cut quality produces clear and more precise cuts. With narrower cuts, smaller heat affected zone. So it requires a less post cut cleanup. So there should be an electrical power source and a compressed air gas. It is less portable compared to for the field work. Cost is initial higher equipment investment, but offer lower operating cost in the long run due to speed and less rework. Whereas frame cutting, it uses a chemical reaction, that is rapid oxidation, where the oxygen and the fuel gas like acetylene and propane preheat and burn through the steel. It is limited to carbon steel and the low alloy steel because the aluminum or the stainless steel it forms a oxide layer that prevents the reaction and excels at a very thick metal from 1 by 8 inch to 12 inches, that is 300 mm, sometimes much thicker. It is slower especially on thin materials, but speed remains efficient and consistent on very thick sections. Produce a wider curve and rougher surfaces, more slag and larger heat affected zone requiring more extensive post cut processing or post cut cleanup. It is highly portable, requiring only gas tanks and a torch setup, ideal for construction sites and fieldwork without electricity. Lower initial equipment cost but a higher operating cost like oxygen gas cost and higher potential high labor cost for the cleanup. So these are the difference between plasma cutting. So is in the stainless steel and the other it causes oxide layer which prevents the reaction, but initial cost is lower compared to plasma cutting. Plasma cutting how uses cuts using a high velocity jet of ionized gases or plasma arc, whereas in oxy-fuel, oxygen and a gas fuel gas preheat and burned through the steel. It is melting and expel metal because of the high temperature, whereas this one burns through the steel. It's a difference. So we're discussing plasma cutting. It is not both the gas torch and plasma cutting is used can be used for the carbon steel, but the stainless steel it is not allowed for the flame cutting because flame cutting make oxidization and prevents the reaction and hence it is not cannot be cut properly, can damage the stainless steel. So plasma cutting it's a high ionized glass or plasma arc which due to high temperature it melts and expel the metal. For thermal cutting is such for low carbon and low alloy steels and place less than 25 minutes cold shearing may be used for plates between 11 mm to 25 mm thick. Cutter should be dressed back at least 2 mm by machinery or grinding. Edges should be inspected for MPT or DP method, die penetrant method. So end profiles have to be butt welded as per ASME B16.25. The socket weld joints should be cut square. All surfaces will be prepared by grinding or machining to clean bright metal, and prepared welding ends shall be examined by ultrasonic for a distance of 50 mm back from the bevel edge. to ensure freedom from laminations and magnetic pulse inspection on bevels. Use of arc air gouging shall not be permitted. Branch connection cutouts shall be carefully beveled and accurately matched to form the suitable groove for welding to permit complete penetration of the welds. So this is also completed. Now point number 5. And now we will continue with uh, point number 5 tomorrow. Okay, thank you.